transformations, sequences, meaning we're going to do one after the other. So where will our figure be? Where will it land if we do a rotation and then a translation? If we do a reflection and then a rotation, or a translation and then a reflection? So any mix of those three. So we're going to be mixing together all three of our different transformations. We won't be using dilations, just these three. One thing I would like everyone to do is if you have notes from last week and the week before, get those out. The notes we're going to be using today are the ones that look like this. So we had rules that we came up with for these three different transformations. So they look like this. Old XY does a rotation of 90 degrees, and then the new one is what? So remember how we did that for all three of our different transformations? We're going to rely heavily on those notes today. So I need to step out really quick. I'm sorry about this. I'm running a little late. So I'm going to step out for like 2 minutes, get your notes ready from last week, and then we're going to put them all together for today and try some sequences of transformations, mixing together these three. Also, take a moment and welcome our new student, Jacob. Hi, Jacob. Thanks for joining. I'm glad you're here.
Hello.
Hello. So go ahead and say hi to him in the chat or with your mic. We're going to be starting the new unit, Jacob, on Wednesday. That's my plan. But I still thought it'd be good for you to join today. So if you like, you can just follow along. And if you feel like you're ready after today, definitely try the mastery test and Edmentum that goes with this lesson. Otherwise, we can work out a plan to have you do the previous work
All right, that
independently.
was
Yeah, for sure. But I just wanted you to come and get used to the whole process. Savannah, you're awesome. Okay, guys, give me a second. I'm really sorry. I'll be right back in 2 minutes, and then we'll get started. Okay. Okay, perfect. Thank you for waiting for me. I guess that's one benefit of being on Zoom instead of in person. All right. So, with your notes in hand, and let's see, Anaya's still joining. It's taking a second for the computer. I wanted to start today by just putting together all of our rules kind of on one page. Help me out if you can. These different notes that we took from before. I want to put together all the rules for these three rotations, reflections, and translations. Let's see. Looks like she's still having trouble joining. Can you guys hear me okay? Is my connection good or am I choppy today?
I can hear you.
Thank you, Victor. Okay. Welcome, Anaya. You haven't missed much. We're just going to put together all the rules that we found previously in the last 2 weeks for rotations, reflections, translations. Let's start with rotations. And just so we're clear, I would like everyone to take these notes down so that way you have all the different rules together on like one sheet or close by together. So let's start with rotations. To do a 90-degree rotation, all xy's on your original figure turn into what? Can anyone tell me from our notes? You can type it or you can say it out loud. Let's see, there is something in the chat. Oh, don't be sorry. It's okay. I'm glad you're here. In your notes, though, can anyone tell me the rotation for a 90-degree rule, please?
Pretty sure that they would become, x would become negative. And then y might possibly continue to.
Can you hear me?
I can hear you. Was that Anaya? I also had Levi talking at the same time. Sorry, guys.
Oh, sorry.
So Levi was saying x goes negative, and then what happens to y?
I'm pretty sure y stays positive, depending where the point is going.
That's right. So here's what I think. Let's see. I'm going to say the x portion becomes negative. Is there anything else there? Is this going to be negative x comma y, or do those get flipped for a 90-degree? Anyone else with your notes? Levi and anyone else? Help me out. XY turns into negative something something.
They flip.
They flip. Thanks, Levi. And in the chat, flipped. Awesome, Anaya. Thank you. So all your original XYs, points from your original figure, turn into negative YX. Next up, 180. All XYs turn into what?
Negative x, negative y.
Wonderful. Thank you. And then the last one we did for rotations was 270. That's like doing 3 90s in a row. And what did we find for this? Anybody?
Y, negative x.
Y, negative x. Awesome. So they flip and the original x number turns negative, or your new y space, the second space, becomes negative. This is like the opposite of what we see for the 90-degree. Awesome, guys. Thank you. And then we could say 360, but I don't think any of our work will really do that. But if you did a 360, you don't change it. It just stays as XY. And that's why we don't usually use that one. Okay, next we'll look at reflections in the middle of the screen. Now we did 4 different lines of reflection. Most of our work is going to really focus on just using the 2 axes, the y-axis or the x-axis. But I also want to review doing the special lines, y equals x line or y equals negative x line. So first up, let's do the y-axis. If I reflect over the y-axis, all xy's turn into what? Uh-oh, I'm losing people. Does anyone have this handy in your notes? Oh, I spelt reflections wrong too. Reflections. Sorry about that. Okay, it sounds like no one has this. Really? Okay. If we do a y-axis reflection, the height stays the same. Remember that? If we're folding over the vertical axis, the y, so the height stays the same, but the x is made negative. So all xy's turn into negative xy. Then we did an x-axis reflection. Remember, this is our horizontal line, right? So if we started, just a quick example, if I started right here for my ABC, my original, but I folded over the x-axis, that's the horizontal, it folds downward. So notice how the x numbers stay the same this time, but the y's all get made negative. All original heights are folded downward. So all xy's turn into x negative y. Does anyone have the notes handy for what we did with the line y equals x?
I'm pretty sure I have the notes. I just have to find them.
Oh, for sure. Thank you, Levi. This is where things get even weirder for these two lines, the line y equals x, and then after this, we'll look at the line y equals negative x. So we need to do both of these. I'm going to come back to the screen in a second. So this is where we're folding over the diagonals. The line y equals x. Don't worry about the prompt on the left. I'm just using the graph right now. So the line y equals x is this diagonal that goes up 1 over 1, up 1 over 1 forever. A nice clean diagonal, goes backwards the same direction, down 1, back 1. And if I started with a triangle here, and I fold over this diagonal line, then let's track some of these points and see what happens. So if this is A, B, and C on the original, A is at 2, 6. And the new A across from it is at 6, 2. Old B is 2, 4. New B is over 4 up 2. And in this case, I purposely had the C on the new C. It's right on the line. So this is at 4, 4, and the new one is at 4, 4 also. So for reflecting over the x-axis, it looks like we merely switch x and y. So the line y equals x, this is the diagonal, the positive diagonal. Xy's become y comma x. So there's that one. And the last one, we swap them and they become negative. So all xy's become negative y, negative x. So please update your notes now. If you haven't already, let's make sure you have all these rotations on the left and the reflections in the middle. And then in 10 seconds, we're going to look at the translations. I'm going to get that one ready. So for translations, we'll be told that we're moving up or down some units. I'm going to call it A. left or right, some other number of units, we'll call that b. So for all our original xy's, and we're doing a translation, we simply apply the a and the b to their left or right as needed. So for left and right, I'm calling that b. So if we're told to move left b units or negative units, we're going to just, or right units, we're going to add that to the x. And for y's, the up or down number, we simply add or subtract that number to the y. Remember translation? This is the one where we just start with a figure and we're dragging it across the screen up or down and left or right. So let's do a couple examples, and then I've got some examples from the mastery test to show you, and I wanted to walk through with you guys. So if you're taking notes, make sure to have all these written down. The 4 reflections, the 4, or really just the top 3 rotations, and then our translation approach, our translation rule. If you're taking screenshots because you don't have paper at home, get your picture taken on your phone or a screenshot of all this. If you're typing, let me know if you need more time.
I just need a little bit more time. I'm finishing writing down the last of the translation.
No problem, Levi. Thank you so much for telling me. I don't want to leave anyone behind. Make sure you do have them all, though, because what we're going to be doing today is at least 2 of these in a row, and we'll be told, do a rotation of 180 degrees and then a translation of up 5 and over right 4, something like that. So we're going to take an original point and track where it goes doing each one of these moves. So we know its original starting and its final ending after doing 2 or more different transformations. That's the idea. So the good news is we're not really doing anything new, but it's complex because we're mixing together all the things we've done at once. And I'm going to write down my reflection rules as well. Okay. All right. No one else is saying we need more time. Levi, are we good to go for you?
Yeah, I'm done.
Okay. Thanks for telling me. I hope everyone else is ready. I don't want to leave you guys behind. Let's try a problem. I'm going to erase what I did on this graph. There we go. Okay, so reflect ABC across the x-axis and then translate along the vector -5, 6. So this vector, it's telling us it's a translation and it's telling us these numbers, -5. So that's going to be like going left because the first number always goes with x, right? Horizontal. The second number, that's up or down. So since it's positive, we're going to go up because that always goes with vertical. So there's no ABC on here. Let's I'm going to use something from the first quadrant like normal. So I'm going to make a triangle ABC. Make it kind of a long looking triangle. And I want to know exactly where ABC lands after we do both actions, both transformations. First, we're going to reflect across the x-axis. And then secondly, we're going to translate the vector -5, +6. So first up, the reflection. Our original point for A is 2, 5. I was practicing extra with a couple folks who met with me last week, and really great job, and thank you both for joining me. I think we got a lot of good stuff done. And one of the things we practiced was just naming where points live on the coordinate plane, which is something I think everyone can benefit from. So point A is to the right 2 and then up to this line, which is the 5. So original A is 2, 5. We do our reflection. Our reflect across the x-axis rule is it becomes x negative y. So our original x is 2, our original y is 5. So A prime is 2, -5. We're going to do the same thing now for all three, or for the other two. So let's locate B. Can anyone tell me, on looking at my screen, where does point B live? The original. Where's the original point B? We want to find its x and its height. Oh, awesome. In the chat, I see one comment, 2, 3. Savannah, high five, dude. Exactly. How did she get 2, 3? She looks at point B and she looked down for its x number. It's right at 2. She looked to the left to find its height at a 3 there. So we do the reflection, and new B is at 2, -3. We're using the reflect on x-axis rule. And now for C, can anyone tell me what's the original point for point C right here? Original point for point C. Anybody? To find its x, look down at the from C, the point we're interested in. Look down towards that line, the x line. Where does it look like it is? Oh, I see someone in the chat. Tatiana, high five, dude. Yeah, it's to the right 5. And how high is it? 3. Good job, Tatiana. So original C is 5, 3. We do its reflection across the x-axis, and the new C is at 5, -3. So now we've done each point, A, B, C, and reflected it across the x-axis. Let's see where that would live on our picture. So for A prime, it's 2, -5. I'm looking at my list that I just made. 2 and then down 5. That's A prime. 2 down 3 for B prime. And then C is 5 down 3. So here's our reflection. Woohoo! Now we need to translate this image, the purple one, left 5 and up 6. So every one of our points, A prime, B prime, C prime, needs to go left 5 or -5 from where it is, and then up 6 from where it is. Let's try this in blue. No, blue's not good. Let's do orange. So now I'm going to kind of write out my steps on the left here. So from A prime, B prime, C prime, we're going to use this vector, -5, 6. So that's like saying 2 minus 5, and then -5 plus 6. Let me change that. Two minus 5, and then -5, because that's already the y number, plus 6 from the vector. So 2 minus 5 is -3, and -5 plus 6 is +1. So it looks like my final resting point for A, I'm going to call this double prime because we've done a second move, is -3, 1. So starting from the very origin, the very middle, we go left 3 and up 1 for my new A. And if we do it with B, I kind of didn't give myself enough space. Sorry about that. So here below, we'll do it in orange. So 2 minus 5, and then 6 from the vector, minus 3 from the point. I should say -3 plus 6, shouldn't I? Here we go. -3 plus 6. So we combine each of those. 2 minus 5 is -3. And -3 plus 6 is +3. So my final resting point for B double prime, -3, 3. So left 3 and up 3. And if we do the same thing with C, for the C work, I'm going to do that in the middle here. So C double prime will be its original x and y. So that's 5 and -3. And then we have to apply the vector, which is down 5 for x and up 6 for the y. So 5 minus 5 is 0. -3 plus 6 is 3. So we have 0, 3. So 0 left and right, up 3. So there, right on the y-axis, looks like is the new C. And if we connect those, we have the new translated triangle. So in red on our image, we have the original ABC. Then we did a reflection down to purple, and then we did our left 5, up 6 translation. 1, 2, 3, 4, 5. Yep, it seems like it's working. 1, 2, 3, 4, 5, 6. So yes, if you're working with a graph, you can just count the B prime, A prime, and C prime left and up. But if we're not using a picture, we have to rely on using the rule for a translation. It's been a week, but we did use vectors last week to do our translations. So sometimes it'll tell us like move left 5 and up 6, or it might present it to using a vector as well. So we have to be ready for both. Okay, so 11:33. Let's try another one with 2 different transformations. And I also want to start with the same ABC. I think that'd be a good idea. So A 2, 5, B is 2, 3, and then C is 5, 3. Here we go. So this time it's saying rotate ABC 90 degrees and then reflect it across the line y equals x. So here's our 2 transformations. Rotate 90 and then reflect across this line y equals x. So let's put in our original triangle first. And I'm going to use the same exact one we did last time. So A is at 2, 5. B is 2, 3. And C is 5, 3. Now we're going to follow some different directions, different transformations. So let's list our original points on the side. And they're the same as last time. So A is 2, 5. B is 2, 3. And C is 5, 3. Okay, so now let's start by doing our rotation of 90 degrees. I'm going to change my color to purple for this first transformation. So we're using the rotate 90 degree rule. So look at your notes. To rotate 2, 5, point A 90 degrees, we should be doing negative y x. So that means our original is 2, 5. But they flip, and the first location gets negated. So it's going to rotate, or flip, I should say, to 5, 2, and that first spot is negated. Negative 5, 2. Negative 5, so that's over here, counting from the origin to negative 5 on x and then up 2. So there's the new A prime. Now we need to do the same thing for B and C. So let's look at point B. It's the same rule that's applying to all three of these. We flip them and the first spot gets negated. So 2, 3 for B should turn into 3, 2. But we need to also negate the first space, the x space, the old y. So we have negative 3 up 2. And then for C, flip them and negate the first space, following that rotate 90 rule. So we have negative 3 up 5. So negative 3 up 5, and here's our 90 degree rotation. Now we need to do our final transformation. We're going to reflect it across the line y equals x. So just as a reminder, the line y equals x is this positive diagonal going upwards. I'm going to draw it in here with dashes. So imagine taking our purple triangle and reflecting it diagonally over this line. Okay, for space, I'm going to rewrite my rotated points, and we'll then do the reflection rule to each one. Okay. Reflect on y equals x. So what's our rule for reflecting across y equals x? We simply swap x and y. So all xy's become yx. So if I swap a prime, x and y, what do we have? Let me ask my question again. If I'm looking at just a prime, which is negative 5, 2. If I do the reflect on the line y equals x rule, I'm swapping x and y. So what would my a double prime be if I swap x and y from a prime? Anybody? Nobody. Look at what we have so far for A prime. We've did our rotation from the red triangle to the purple. And where's the new A prime? It's at negative 5, 2. Our notes say to do this reflection across this line, y equals x, we simply swap whatever we have for x and y. So if I swap those, we have 2 comma negative 5. And if I swap for, oh, go ahead, Levi.
Now, I was looking at back on my notes. I got confused for a second, but so because we did a 90-degree rotation already,
Yes.
now that we're doing another rotation, I'm pretty sure that would put it at a 180-degree rotation.
Oh, hang on, Levi. You're on the right track. We did our rotation of 90. The second move we're making, or transformation we're making, is the reflecting across the line y is equal to x.
Okay.
So you're right. If we were doing 290s, you're totally right. We would be doing a total of a 180 rotation. But starting from the A prime, B prime, C prime, and I've got those written out on the left side of the screen, doing our reflection across this specific line means, let me write it again here. I'll write it at the top. Reflect on y equals x. This rule said all xy's turn into yx, meaning nothing gets changed as far as its negative goes, but we do swap their positions. So below for b prime, negative 3 comma 2, we swap those, will turn into 2, negative 3. Look at my before and then the after. B prime to B double prime. Let's try it for C prime now. So I'm at negative 3, 5 for C prime. I swap them. And now we have 5, negative 3. And I want to make my cursor green to kind of keep track of the different moves we've done. And let's put those on the screen now to see where it lives, this final ending place after doing the reflection. A double prime is at positive 2, negative 5. So starting from the middle of the graph, positive 2, down 5, right here. There's A double prime. B double prime, over 2, down 3, right here. And C is over 5, down 3. And there's its final spot. So from red to purple, we did a rotation, 90 degrees. Then we did a reflection against that diagonal line. So for all the problems in this mastery test, it's going to be similar to what we just did for the last two examples. We'll be given a figure, usually a triangle. We'll be told to do at least two different transformations to it, different moves. We've got to use our notes, those rules that we've come up with, to do each move one at a time to find its final resting place, its final position. Like I have in green, where this triangle finally landed when we were done. Let's try one from our mastery test. Actually, not that one. Here's a good example. I just took it straight from the mastery test so you could see what it's like. So they give us a graph with triangle ABC graphed out. And then below in words, it's telling us triangle ABC is translated 2 units down and 1 unit to the left. Then it is rotated 90 degrees about the origin to form A prime, B prime, C prime. So first move will be in green. Second move is rotating 90 wherever we got in green, wherever we got after doing our translation. And then they want us to list the final points for A, B, and C in the boxes. So let's try this 1 point at a time using our 2 different transformations. We change back to green here. So first step is we need to locate what are A, B, and C to begin with. So let me ask you guys to help me out. Using the graph that they gave us, can we locate A and B and C? Go for it.
So A would be 0, 0.
Very good.
C would be negative 1, 1.
Yes, it. I think it's supposed to be. You're on the right track. It's 1, 1, just positive, positive.
Okay. And then 3, 1.
Good. And we need to list the X number first. So it'll be positive 1, 3. Good job. Thank you, Levi. So those are our 3 like starting numbers or points, coordinates. And I'm going to go ahead and list them on our white like space there. So I'll list them in A, B, C order. So A, B, and C. Levi found them 0, 0. B is 1, 3. And C is 1, 1. Okay, so now I'm going to change to green so we can do this translation. So the new point we land at will be going, look at the instructions, translated 2 down and 1 to the left. 2 down, that's going to apply to the Y numbers, to the second number in each coordinate. And then 1 left will be -1, because if I go leftwards, arrow going left here, that's like going in a negative direction. So left means do negative. And if they tell us to go down, that's also negative. Negative for the Y though. Y number. Negative for X number for left, negative for Y number for down. So let's do this with A, 0, 0. So if I am at 0, 0, I'm going to write it out with some space like this. But I go left 1 unit, that's -1 unit. That's my left 1. And then it also says 2 down, so I'm going to go -2. That's where the down is coming into play. And if we simplify, 0 minus 1 is -1. 0 minus 2 is -2. So there's my my new A point. Really, I would like to call this A prime, but it looks like they're calling the final A prime. So that'll be our double prime, or the final one will be our double. Okay, so now we got to do the same thing for B and C. So the original B was 1, 3. But now we're going to apply the same rules we just did for A though. So down 1, or I'm sorry, left 1 and down 2. So 1 minus 1 is 0. 3 minus 2 is 1. So there's the new B. C started at 1, 1. But we have to still apply this left 1 and down 2. So this new C is at 0, -1. Okay, let me scoot that over for some space. Okay, finally, we're going to do our 90-degree rotation. So I'll put this in red because it goes with, in the words, 90-degree clockwise rotation. So, and we're not changing the purple points, we're changing the green points because we've already done a translation to those. And then finally, what we get for red, for the final A, the final B, and the final C, these will be our answers. Okay, the 90-degree rotation rule from our notes is what? Just as a note here, 90 degrees rotate means all x, y's turn into negative y, x. So I look at my A. Let's do this. We'll do the A first. The original x is -1 and the original y is -2. So I need to swap positions. So it'll be -2, -1, and we have to change our y number, the -2, to positive because of that negative y in the rule right there. So our final resting place for A should be 2, -1. Let's do it for B. The rule says xy's turn into -yx. So B prime is 0, 1. We swap the positions, change the positions, so it'll be 1, 0. And we turn negative the old y number, or what's in the new x space, the 1. So -1, 0. And now for C, the old x is 0, -1. xy is 0, -1. We swap them. And we got to change the sign on that old y number. So -1 actually is going to be +1. 1, 0. And finally, we're done. We found each location after doing the translation in green and then the rotation in red. I see it's almost time to go for today already. I'd like to do one more with you guys so you get more practice in seeing this work. Are there any questions right now before we do our last example? You can type them in the chat or you can just ask, either way.
I don't have any questions.
Okay, thank you, Levi, for telling me. Your homework today, everybody, is to try doing the mastery test in, oh, don't leave, is to do the last mastery test in this unit. Let me see what that's called again. It's called Predicting Results of Rigid Transformations. If I wrote this material, I would not have named it that. I would have called it Sequences of Transformations. It's called Predicting Results of Rigid Transformations. It should be our last one in the unit. Okay, let's do another example. This is a multiple choice. Which sequence of rigid transformations will not map the pre-image ABC onto the image of A prime, B prime, C prime? So we have a list of 4 different sequences of transformations below. It sounds like 3 of them will turn ABC into A prime, B prime, C prime. One of them will not. So let's look at ABCD. The choice is ABCD and see if we can eliminate or rule out any of those options. So option A, a reflection across the y-axis followed by a reflection across the x-axis. Let's track this for just one point. So looking at option A, I want to do these 2 transformations and see if it gets me from my original point to my ending point. Let's try tracking point B. So I'm going to look up at my picture, Point B is at, what's its x and what's its y? And I look down to the x ruler and it's at -4. I look over to the y and it's at +6. So original B is at -4, 6. If I do these two transformations from option A, the first one listed, will that give me the new B at 6, -4? Let's see. So B is at -4, 6. Let's do a reflection across the y-axis and then a reflection across x. Reflect y first. Reflecting on the y-axis doesn't change the height, but it negates the x. So it changes from positive, negative, or negative to positive. So my new B, after reflecting on the y-axis, will be 4, 6. So I'll put that on my graph just to kind of visually keep track of that. So B prime would be 4, 6. And then I reflect on the x. Axis. And what does that do? That keeps x the same but negates y. So x stays the same, but y gets negated. So it looks like the final resting place for point B, B double prime, will be 4, -6. And it looks like if I go back to my graph on the left side, 4 down 6, that is where the A prime is landing. So yes, there's a point there, but it's not enough for us to be like, oh, well, there's a point there. It needs to be the exact match. I wanted this to be B double prime, but it's not, is it? The B final B point is this one. They're calling it B prime because they're not naming the second set of points. I wanted to name each set of points so we would know each stage of changing it. But those are not a match. So it looks like we've already found the one that is not mapping the pre-image onto the image. If we were, if this had lined up, and if it had given us the correct landing point for B prime or B double prime, then I would move on and try the next option, option B or option C, until I finally got one that didn't work. But it looks like we've already found it with A. And it's pretty close to noon, so I think I'm going to stop there for today. I would like to have you guys all work on the mastery test. So today, don't put it off. Don't wait till tomorrow, or don't say I'm going to do it tomorrow or do it Thursday or something. Do it now, because tomorrow we're going to